Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to graph logarithmic functions. In the last lecture, where we introduced logarithmic functions, we showed the two graphs. The first graph here is where b is bigger than 1, and we notice that we have these two important points, 1, b comma 1. And here b is between 0 and 1. Again, you have 1 comma 0 and b comma 1 as important points. You have vertical asymptote. So we need to see what doing transformations do to these graphs. So if you add c to the function, then it's going to shift the graph c units up. You subtract c units down. If you subtract within what you're taking the log, add within what you're taking the log of, it's going to be c units to the left. If you subtract, it's going to be c units to the right. A negative in front of the log reflects a graph about the a transformation about the x-axis, or reflection, about the x-axis. And then a negative inside the log represents a reflection about the y-axis. So let's look at a couple of graphs. We want to graph, first of all, f of x equals log base 3 of x. And we've already said that 1 comma 0 is the x-intercept. And then we look at b comma 1. Here b is 3. So 3 comma 1. And our graph has that vertical asymptote. So our graph looks something like this for f of x. Now for g of x, we have f of x, log base 3 of x plus 2. You're adding 2 within the function, so this is going to move g of x 2 to the left. So let's see what happens. If this moves 2 to the left, this point moves 2 to the left, our vertical asymptote will also move 2 to the left. So this is the graph of our g of x. So our vertical asymptote moved from x equals 0 to x equals negative 2. Our domain, remember, of the original log base 3 of x is from 0 to infinity, but since we moved the graph over 2, it's going to be negative 2 to infinity, and our range is negative infinity to positive infinity. Let's look at another one. We have 2 plus log base 3 of x, so this shifts the graph 2 units upward. Let's go ahead and graph log base 3 of x. We have a point 1 comma 0, 3 comma 1. So when we push the graph 2 units up, this point goes up 2. This point goes up 2. If you notice, the vertical asymptote does not change. So our vertical asymptote stays x equals 0. Our domain, just shifting it up or down, does not change. And our range is still negative infinity to positive infinity. All right, so let's graph g of x equals natural log x plus 1. Now, we didn't go in depth with natural log, but y equals log base e of x is natural log x. That's an abbreviation for that, and that's a lowercase l n. So to graph this, you're still going to have the point 1 comma 0, and you're still going to have b comma 1. Here our base is e, which is 2.71 comma 1, which is about there. And you still have the vertical asymptote. So when we look at natural log of x plus 1, this shifts the graph 1 unit to the left. So what happens is our vertical asymptote moves over 1 unit. This moves over 1 unit, and this moves over 1 unit. So this is the graph of our g of x. So our vertical asymptote is now x equals -1. Our domain will change to -1 infinity, and our range will be -infinity to infinity. So remember that Dr. LB is always in. Please come back for more math help.